Welcome back, focused learners. Today's explainer is an absolute game changer if you're prepping for your fitness certification exams. We are demystifying GETP 12 Appendix D. Now, if you've opened up this section of the text, you already know it looks like a giant, intimidating wall of complex formulas. But hey, don't panic. Today, we're going to crack the code with a highly targeted memorize versus understand strategy. This approach is going to save you hours of unnecessary study time, literally eliminate that test anxiety, and give you exactly what you need to crush your exam. Okay, let's dive into this. Here is your high-yield roadmap for today. Estimating 1 rep max, predicting maximum heart rate, field and submaximal VO₂max, skinfold body composition, and finally, the ultimate study priority. Starting with Section 1, Estimating 1 rep max. I'll tell you right now, this is a high-yield, must-memorize zone. I want you to mentally grab a bright red highlighter for this concept. To understand why we even do this, we have to ask a foundational question. How do we actually find max strength without risking injury? A true 1-repetition maximum is the gold standard for measuring strength, right? But let's be realistic here. Putting a beginner or, say, a severely deconditioned client under a true maximal load, that is a massive injury risk. It's dangerous and, frankly, it's usually unnecessary. The crucial solution is estimation. We use submaximal sets where a client lifts a much lighter weight for a certain number of reps until they hit fatigue to safely estimate what that true 1RM would be. So look right here. This is Table D 1.1. Memorize this table. Seriously, burn it into your brain. What you're looking at is the conversion from reps completed directly to the percentage of a 1RM. 1 rep is 100%, obviously, but scan down the column. 4 reps is 90%, 8 reps is 80%, 10 reps is 75%. You absolutely need to memorize this because it's a two-way street. You can use it to estimate a max from a submaximal set or, and this is great, if you already know their max, you can use these exact percentages to accurately pick a training weight for a specific target rep range. Let's walk through the math so it clicks perfectly for you. Imagine you have a client who lifts 100 pounds for exactly 8 reps. We know from the table we just looked at that 8 reps correlates to roughly 80% of their true max. So to find their estimated max, you just take the weight, 100 pounds, and divide it by that percentage as a decimal, which is 0.80. 100 divided by 0.80 gives you 125 pounds. Boom! It's really that simple. Know the percentage, divide the weight by the decimal, and you've got your answer. And that quick math we just did brilliantly illustrates the mechanics behind the two primary prediction equations you're going to see, the Brzycki equation and the Epley equation. Now, both rely on 2 key variables. You've got W for weight and RTF, which stands for reps to fatigue. Brzycki uses a subtraction model in the denominator, while Epley is an additive multiplier. But here is the critical exam tip. Both of these equations are really only highly accurate for 10 reps or less. As the reps creep higher than 10, the accuracy drops off significantly, which is exactly why our previous table stops being perfectly linear at those higher rep counts. Moving on to Section 2, predicting maximum heart rate. Flag this as a priority area. Now, what's really interesting about this is that you do not need to memorize every single number here. What a relief, right? You only need to memorize Tanaka, 208 minus 0.7 times age. That is the preferred formula for healthy males and females. Commit that one to memory for sure. For Astrand, Gellish, and Galati, you literally just need to recognize them by name and know the populations they serve. For instance, knowing Galati is specific to asymptomatic middle-aged women. And that old 220 minus age Fox formula at the bottom, it has a massive margin of error and is basically a dinosaur at this point. Know it exists, but avoid using it if you want real precision. Once you predict that max heart rate, you use it to find the target heart rate. We have 2 main methods to look at. The HRR, or Carvonen method, actually factors in the client's resting heart rate. You take the max minus resting, multiply by your intensity method, is way simpler. Just max HR times the intensity percentage. But keep this firmly in your back pocket for the test. The HR max percentage method will always yield a lower target number than the Carvonen method when you're calculating for the exact same intensity percentage. All right, Section 3, field and submaximal VO₂max. We're radically shifting gears because this is strictly an understand, don't memorize section. Priority alert, everyone. I know exam anxiety completely spikes when you flip to Appendix D and see massive lines of complex regression coefficients and these incredibly long decimals. Listen to me very carefully.
Do not memorize those long decimals. You do not need to be a human calculator for this exam. You simply need to understand the tests themselves and know what specific pieces of data each test uses to generate its result.
Let's rapidly break down these 4 key tests so you know exactly what to look for. The 1.5-mile run test measures time. Quite simply, a faster time equals a higher estimated VO₂max. The 12-minute Cooper test measures distance. More distance equals higher VO₂max. The Rockport 1-mile walk is fantastic for lower fit populations. And for that one, you measure walk time, ending heart rate, age, sex, and mass. Finally, the 6-minute walk test measures distance covered in 6 minutes to estimate functional capacity, and it's heavily used for clinical or older populations. Again, just know the inputs for each test. The whole reason you don't need to memorize the math is because it all boils down to this singular quote. For a given effort, covering more distance, a faster time, or a lower exercise heart rate equals higher fitness. I absolutely want to emphasize this foundational principle. Let it sink in. Every single one of those terrifying regression equations in the textbook is literally just encoding this basic, unshakable truth into a formula. If you understand the concept, you understand the tests. Section 4, Skin Fold Body Composition. Let's look at the 2-step logic and the measurement sites. Let's see how this builds into our 2-step logic for skin folds that the exam definitely expects you to comprehend. Step 1, we take the physical pinches of fat, the sum of the skin folds, and we convert them into body density using the Jackson-Pollock regression equation. Then, step 2, we take that newly calculated body density and translate it into a final body fat percentage using either the Siri or Brozek equation. Pinches to density, density to percentage. That is the rule of thumb translation you've got to remember. Alongside that logic, you've got to know your sites. The exam cares deeply that you know these sites are sex-specific and that they exist in either 3-site or 7-site groupings. The 7-site locations cover the chest, mid-axillary, triceps, subscapular, abdomen, suprailiac, and thigh. But take a close look at the 3-site lists. Men are tested at the chest, abdomen, and thigh. Women are tested at the triceps, suprailiac, and thigh. This directly reflects the biological differences in how men and women naturally store body fat. Know your groups and know the differences. Which brings us to Section 5, the ultimate study priority. So what does this all mean for you? This right here is your ultimate cheat code. Honestly, take out your phone and take a screenshot of this matrix right now so you can study efficiently. 1RM estimation and target heart rate are high priority. Memorize the table, know how to use it both ways. HR max formulas are medium-high. Memorize Tanaka, recognize the rest. Field VO₂max and skin folds are medium priority. Know the test requirements, know the skin fold sites and the underlying logic, but completely skip memorizing those regression coefficients. By separating what you absolutely must memorize from what you simply need to intuitively understand, you have just saved yourself hours of frustration. This structured approach clears away the noise and leaves you with just the vital facts. So I'll leave you with this. What if the biggest barrier to passing your exam isn't the difficulty of the material at all, but simply how you choose to filter out the noise? Trust this framework, stick to your study plan, and you are going to do amazing. I'll catch you in the next explainer.